Welcome back once again, 7th graders. We are on lesson 6-7. I can graph translations on a coordinate plane. Translations being yet another vocabulary word for chapter 6. And we will begin on page 337. So, translations are slides. You think if I'm going to translate, I'm going to slide. Okay? So, translation, something called a slide, is the movement of a figure from one position to another without turning it. Okay? So, if you're going to slide through the kitchen on your waxy floors, that's a translation. If you don't pivot, pretty much, you don't not turn. Okay? So we are going to draw a translation, and you have your notes, so please make sure you're making use of those. So our first one is to draw a translation. We're going to copy a trapezoid, W, X, Y, Z, which is shown on the right, and you'll put that on your graph paper. It's already there for you. If you don't have that, you'll have to put it on one. And we are going to draw the image. Remember, image was the transformation. So this is after we move it. After the translation, 4 units left and 2 units down. So remember the vertex. We have the vertex of the trapezoid. 4 units left and 2 units down. Left is this direction. Down is this direction. So you can show that on here. Each vertex is going to go 4 left. So 1, 2, 3, 4, and 2 down. That means W prime would end up here. 4 left, 2 down. X prime is going to end up there. 4 left, 2 down. W prime is going to end up there. And 4 left and 2 down. Z prime is going to end up there. Okay, and that's shown again in your book like this, just dashed over and making the points. And then you connect the vertices of the images. So really not too bad, just if you know directions and you can move right up and down, then you should be in good shape. That is the longer, more graphy, more drawing spot. The more computing is what I'm going to show you next. Okay, so translations on a coordinate plane. So we have graphed, and you may need to get this on your graph, on your sheet, because it's not on there yet, for example, 2. So you need to graph J at -3, 4, -3 at 4, J, K at 1, 3, and L at -4, 1. So you're going to plot those points. And then you're going to graph the image, remember the prime after the transformation, after you translate 2 units right and 5 units down. So that's 2 to the right, 5 down. Okay? Hopefully what you know about left and right is anything to the left of X on the origin is negative. So what we could actually do is think of to the left is negative, to the right is adding. Subtraction would be a negative, like going down. So if you're going down, you subtract, and going up, you add. So another way to show this, instead of me doing the, 2 over 1, 2, 3, 4, 5 down, and getting all my lines crossed, which I can still do, no problem, but it could get a little messy, okay? So I could do that. Or instead, another way to show this would be to mark your original points. So J's original points are -3, 4. And then change them by, we're going to the right 2, and that's on X. X is always left and right. Y is up and down. So that's to the right 2. So we do -3 plus 2, and that's Y, 5 down, so -5. So that means J prime would be at -1, -1. Is that right? Did I make a mistake there? Maybe I did. Count down 20, 1, 2, 3, 4, 5. Okay, and look at that. J prime is at 1, -1. Okay, so that's kind of a way just where you can get them and not have to draw the lines. You can just plot your points. So if we continue doing that for K, I went down 2 times 2, 1, 2, 5. So my original point was 1, 3, and I'm changing 1 by going up 2, or going to the right 2, changing 3 by going down 5. So I end up K prime at 3, -2, which is also true. So then L, I started at -4, 1. This kind of like scale factor when we multiplied, but now we're adding or subtracting based on the direction we're going. So we have -4 going to the right 2 from there, and we're at 1 and we're going down 5 from there, making our L prime units at -2, -4. -2, -4, so our L prime would have ended up to be. And you still have your same congruent figure, but translated down and to the right. Notice, down and to the right. So X and then Y. This is another way to show it. Pretty cool. Noticing there's just a study tip on the right here. It's kind of a long one. It just says that on a coordinate plane, a translation can be described using that ordered pair. Translation up to the right is positive. A translation down and to the left is negative. So what this 2, -5 means, like we have here, translate 2 to the right, 5 down. So that's kind of what just shows what we did. Okay? And in your book, it shows the same example. They just always say add, but I think subtracting is easier than adding negative. So that was just your book's example, which is fairly similar to ours. So I think we're in good shape there. So check your progress here. Triangle ABC with vertices 4, -3. So we're going to start plotting right away. 4, -3 over 4 down 3. B is at 0, 2, so 0 up 2. 0, +2. And C is at 5, 1. So +5, up 1. Better connect those points. Okay. And looks like we are moving this 2 units down. It says nothing left or right. So that means, and we have to know that X controls our left and our right, and Y controls our up and our down. So this means we're going to be changing our Y coordinate by going down 2. So another way to show this here. Okay, so we could show with our line. So we're going to go 2 down. So B is going to end up here. C is going to end up here. A is going to end up here. And our new figure overlapping. Okay, to show that, what we would have done too with our coordinates was just do, well, A, we were going to take our original 4, add 0, take our -3, go down 1, that's subtracting 2, which leaves us with A prime at 4, -5, which we actually did. Okay, so doing that, knowing to go down 2. Same thing here, 4 units left, 3 units up, so we have to plot that same first original point. So we go 4, -3 again, A. We're going to go B is 0, 2. C is 5, 1. This time we're translating it or sliding it. 4 units down, so -4 from the X. 3 units left, which is negative, subtracting 4 from X. 3 units up, which is adding 3 to Y. So for A, we're going to do 4 -4 and -3 plus 3. So A prime is going to end up at 0, 0. B, we're going to change 0 -4, 2 plus 3. Notice I'm just taking the originals and changing them. So B prime is going to end up at -4, 5. And finally, C, we're going to change 5 -4, 1 plus 3. So C prime is going to end up at 1, 4. Let's check our accuracy there. So we're going to go 4 to the left, 1, 2, 3, 4. And 2 down, which works. 4, down 2. So B prime did end up that. No, I did move all the way. So I went over 4, left 4, up 3. I went down 3. See, so that's more on the loss problem. Over 4, up at negative 4, 5. For C, this is a little bit more reliable than me counting that way. C, we're going to do the same thing. Left 4, up 3, and we end up where we need to for that, 1, 4. And A, left 4, up 3, we end up at 0, 0, like we said. So kind of a cool deal. You can use either way. This is definitely the more mathematical way, so you want to give that a try. All right, little test example, last thing. If triangle PQR shown on the right is translated 2 units left and 3 units up, what are the coordinates for R prime? So you're translating the whole thing. Can you do this really without using the graph is the question. So you have to know 2 units left is a negative 2. 3 units down is a negative 3. That's our change. So we have to find out what point R is at right now. R currently, the original R, is currently at 4, 2, and we're changing it by this. So we're going to do 4 minus 2, 2 minus 3, which is going to lead R prime to 2, negative 1, which is answered. Okay, there's a couple check your understandings we skipped in the book, so make sure you try those. If you're still confused, write down some notes. Make sure you're coming prepared to class with your note sheet. See you